Hi guys, we are ready for lesson 2-3, applying powers of 10. We're going to be able to estimate powers of 10 to solve multiplication problems and check the reasonableness of products. And we're also going to be able to demonstrate understanding of the place value system. Before we begin, let's do a little warm up to review some of the things we've talked about this week. Taking a look at the numbers 100, 10 to the third, and 10. I want you to convert between standard and exponential notation. So record your answers on a piece of paper or a slate and pause the video, write those down, and come back. Okay, hopefully you had 100 equals 10 to the second because we can see we have 1, 2 zeros. 10 to the third, you looked at that third exponent and saw that we had 3 zeros. And then 10 to the first, we have 1 0 right here. Well, 10 would be 10 to the first power. So we also have a couple vocabulary terms that we want to review. The first one is estimate. Remember, to estimate is to get an answer that is close to an exact answer. To estimate means that you give us an answer that should be close to that exact answer. Then we've got extended facts. Hopefully these are something you remember from last year in 4th grade. It's variations of your basic facts involving multiples of 10, 100, and so on. So for example, 30 plus 70 would equal 100, 40 times 5 would equal 200, and 560 divided by 7 would equal 80. Those are extended facts because we know that 3 plus 7 is 10. We know 4 times 5 is 20. And we know 56 divided by 7 is 8. And you can see on each one of these they've extended it actually by powers of 10. Let's let this, there we go. So how could you do the following problems in your head, using extended facts? So think about 5 times 4. What is that answer? And how could you use this to complete these? Pause the video, think about it. Hopefully, again, you did 5 times 4 would be 20, and you saw that there was just one extra 0, so you could get 200 for this answer. Same thing, 5 times 4 is 20, but then we've got 2 more zeros, so we're going to add on, and it would be 2,000. And then again, 5 times 4 is 20, but this time there are 3 extra zeros, giving us 20,000. Notice, using your information from lessons 1 and 2 and powers of 10 knowledge now, you can see that this is up by 1 power of 10, 10 to the second, and 10 to the third. We're adding on that many zeros. So we can also see up here, it says 5 times 4 times 10, or 5 times 4 times 10 to the first. That exponent should be over here. I'm not sure why it always messes up. But how does rewriting this problem as a product involving a power of 10 help you think about how to use a basic fact to solve that problem? Okay, so going back to this one again, we saw we had 5 times 4, and we knew that it was going up by a 10 to the first power. We're adding on one more. And that's what they show here. We did 5 times 4 times 10 because 5 times 4 is 20. 20 times 10 is 200. This is the same thing. How can having that exponent help us think through that? Okay, so that tells us, remember, the exponents, how many zeros are going to be added on. So 5 times 4 is 20. Add on one more 0, giving us 200. You can write 50 times 40 as 5 times 10 times 4 times 10. This is the same as 5 times 4 times 10 times 10. It doesn't matter which order when you are multiplying, okay? When you are multiplying, the numbers can go into any order that you wish, and you'll still get the same product. We know that 5 times 4 is 20, and then we need to multiply that by 10 2 times, which means attaching 2 zeros. So your answer for 50 times 40 is 2,000. So today we're going to use those powers of 10 and extended multiplication facts to check whether your answers are reasonable, meaning they make sense, and to solve more complicated multiplication number stories. When solving those problems, you're always going to think about whether your answer makes sense or reasonable. One way to do that is to make an estimate. And when we make that estimate, remember, we're getting an answer that is close to the exact answer as possible. This is an important step in determining whether your thinking is on the right track. So here's an example. Miles solved 492 times 63 and got 480,992. All we have to do right now is decide, is Miles' answer reasonable? Does it make sense? And you can use your powers of 10 to think through the reasonableness of this answer. I like to look at a problem like this, and I like to round them. Again, to powers of 10, because I know how to do those extended facts. This is close to 500. 492 is going to round to 500 because that 9 tells the 4 to go up. And 63 is actually going to round down to 60 because the 3 tells the 6 to stay. And if I do those extended facts, I know that 5 times 6 is 30. And then I can see that I have 1, 2, 3 zeros to add on to the end. 1, 2, 3. And I see that with the estimate, now I know my 492 I rounded up, but my 60 I rounded down. My estimate is at 30,000. He got 480,992. Is that reasonable? Probably not, because this one is in the 100,000s, if you recall the place value we talked about in lesson 1, and this is only in the 10,000s. Okay, so using those powers of 10 numbers, I am able to round and estimate to decide. Here's just another example. Rounding to the nearest 10 or 100 creates an extended multiplication fact, just like I showed you in the previous example. And since we know 7 times 7 is 49, we can easily calculate an estimate for this one, 72 times 689. So they did 70 times 700. They got 49,000. So again, this is not reasonable. Again, in the 100,000s, this one's in just the 10,000s. So powers of 10 and estimation can also be used to solve in number stories. A grocery store manager likes to have at least 4,000 cans of vegetables in his storeroom. He has 67 pallets of 36 cans. Does he need to order more? Explain how you figured it out. So when we're looking at this question, I know that he likes to have at least 4,000. So I know that these two numbers probably are going to be multiplied because that's what I've been practicing. And so I know that 67 pallets of 36 cans. So I'm going to take 67 times 36. Well, I don't want to do that just yet. We're not quite ready for our double-digit multiplication, but I am ready for extended facts. So I'm going to take 67 and I'm going to round that to the nearest power of 10, which I'm going to turn into 70. And then I'm going to take my 36 and I'm going to round that one to my nearest power of 10, which I'm going to round to 40. And again, because the digit before it is the boss, so the 7 tells the 6 to go up and the 6 tells the 3 to go up. So I'm going to look at these, and I know that 7 times 4 is 28. And then I see with those powers of 10, I'm going to add on 2 zeros to get my total answer. So this tells me that estimating, he's going to have about 2,800 cans. He's going to be shy of what he needs. He wants 4,000 at least. Does this give him at least 4,000? Nope. He's going to need more. So if the problem had asked us to find the number of cans the grocer needed to order, would we have solved it differently? Probably not. We would have started in the same spot, but then we would have had to have gone a little bit further. We would have had to extend our work past just creating the reasonableness. We would have had to have looked at the number he has versus the number he wants and then decided from there. I'm going to do this example for you. So just sit back and watch. A restaurant is hosting a dinner for 365 people. The restaurant owner has 48 boxes of pasta. Each box makes 12 servings of pasta. Does the owner have enough pasta? Explain how you figured it out. When we have problems like this, we are not being asked to solve the exact amount. We are being asked a reasonableness question. Right here, does the owner have enough pasta? The word enough, that right there is telling me I just need to have a logical, reasonable, does it make sense answer. So I see that we have 365 people. He has 48 boxes of pasta. Each box, that word each box, for each box, makes 12 servings. So I've got 48 boxes, 12 servings. This is what we need. This is the number that's going to help us decide, is it reasonable? So I'm going to take 48 boxes times 12 servings. That would tell me how many servings I have total. Well, I don't need to find the exact answer. Remember, I'm just finding a reasonable answer. Is it enough? So I'm going to do my rounding. So I'm going to round it to 50 because the 8 tells the 4 to go up. And I'm going to round this down to 10. I'm going to show this estimation just a little bit differently, even though I'm sure most of you could do this one quickly. I'm going to remember that 5 times 10 equals 50. And then we've got 10 times 1. So I can rewrite this again as 5 times 1 times 10 times 10. Because remember, it doesn't matter which order. I'm going to come up here. And I know that this is just like saying 5 times 1. Sorry about this. Times 100. Because 10 times 10 is 100. Which then gives us 5 times 100. And our final answer is we have 500. That's the estimation, is 500. So roughly we're going to have about 500 boxes or servings, 500 servings of pasta using 48 boxes that make 12 servings each. Are we going to have enough? Yes, we will have enough pasta. And right here, all this work here helps me explain how to figure it out. So remember, it's always important to work all of your steps out on a piece of paper or a slate. That way, once you're asked to explain, you are ready to go. So turn to page 45 in your math journal. And we're going to talk about this one. A hardware store sells ladders that extend up to 12 feet. The store's advertising says, largest inventory in the country. If you pull out our ladders end to end, you could climb to the top of the Empire State Building. The company has 295 ladders in stock. The Empire State Building is 1,453 feet tall. Is it true that the ladders would reach the top of the building? Explain how you solved the problem. So what I think we need to do is we need to go through and decide, what are we trying to figure out? I see a question right here. Is it true that the ladders would reach the top of the building? So I'm not being asked an exact number. I'm being asked a reasonable answer. The company has 295 ladders. The Empire State Building is 1,400 feet, 1,453 feet tall. Sorry. Each ladder extends to 12 feet. And if we extend them out, if we put all of our ladders end to end extended, we should be able to reach this. So I know 295 ladders times 12 feet each. That's what we would get for the exact answer. But again, we don't need the exact answer. We're looking for reasonable. We're looking for logical. And we know that because of what the question is asking us. I can see that 295 is going to round to 3 times 10 to the second. How do I know that? Ask yourself. Explain that to yourself. How do I know that 295 can be rounded to 3 times 10 to the second? And then 12 is going to be rounded to 1 times 10 to the first. Notice this time I'm using powers of 10 instead of just the multiples of 10. I'm going to rewrite this as 3 times 1 times 10 to the third. How'd I get 10 to the third? Hopefully you saw that we have an exponent of 2 and an exponent of 1 here, giving us the exponent of 3. And then finally, I would say my answer would be 3 times 10 to the third, giving us a final answer of 3,000. 3,000. You would take 295 times 12, round it to 300 times 10. That gives us 3,000. Is it true that the ladders would reach the top of the building? We only needed 1,453 feet. Is it tall enough? Yes. And again, when it says to explain, we've got that right here. We have all of our work here, and that will help us explain. So getting into that habit of writing out all of your work. 1, so you can go back and check it if you find that you've made an error. 2, you can refer to it when it is time to explain your thinking. All right, now I would like you to try number 2. And then you're going to, so I'm going to read this to you. You're going to pause the video, do all of your work, explain your thinking. So you need to answer the question and explain how you solved it. The school library received a donation of 42 boxes of books. Each box contains 15 to 18 books. The library has 10 empty bookshelves. Each bookshelf can hold up to 60 books. Does the library have enough shelf space for all of the new books? Explain how you solve the problem. So go ahead and pause the video now and work this out. Come back when you're finished and check your thinking with me. Okay, so let's take a look at what the book says. Does the library have enough shelf space for all the new books? No. How do we know this? Here's a sample answer. You can round 42 to 40, and 15 to 18 would round to 20. So then you multiply 40 times 20. That gives you about 800 books were donated. I multiplied 10 times 60 to find that there's only room for about 600 books. There is not enough space for all of the new books. So today, we estimated using powers of 10 to solve multiplication problems and check for that's the key word, reasonableness today. Do they make sense? And we're also able to continue demonstrating our understanding of the place value system. Now that you have watched the lesson, it is time to go to your Canvas course and check out today's independent work. See you next time.